Hey everybody, this is Jerry. Welcome back to the Auto Layout video tutorial series. Whether you're creating your views and constraints in Interface Builder or code, the time will likely come when you want to debug what is going on with Auto Layout and why it's putting that view there. In this video, you'll learn some tools for peeking under the hood at what's going on in Auto Layout. When you're viewing debug logs or output from some of the debug methods in Auto Layout, you'll see several different classes of constraints. It's helpful to know what they are and how they're created. The first kind is the one we've all come to know and love, and that's just a regular NS layout constraint. The rest are not constraints that you can create. Their classes are private, but they're created by the framework. Next is NS content size layout constraint, and these are the constraints that get automatically created for a view's intrinsic content size. There's also NS auto resizing mask layout constraint. We talked about setting translate auto resizing mask into constraints to false. So if you're seeing this one in the debug console, it could be because you forgot to set that to false and now you have conflicting constraints. But the system does use this one for top level views and in some other cases, so it's not always evil. Next, there's NSIB prototyping layout constraint. These are the automatic constraints created by Interface Builder if you haven't fully constrained your layout. And finally, there's _UI layout support constraint, which is created when you make a constraint to the top layout guide or the bottom layout guide. There are two types of situations in which your layout might not be doing what you expect. The first is an ambiguous layout, where you don't have enough constraints defined for a view, and we'll talk more about that in a bit. The second is unsatisfiable constraints. In this case, Auto Layout will print a bunch of log information to the console, try to degrade gracefully by breaking one of the constraints, and continue on. If you add an identifier to your constraints, it will use that identifier in the log information, making it a bit easier to identify which constraint is which. All this log information is pretty verbose and has some instructions at the beginning and the end, so let's just take a look at this middle part. There are two constraints defined. The first says the UI button with a caption of button has a leading space constraint equal to the margin of a UI view. The second constraint, with an identifier of space save button, says the same UI button has a leading space constraint equal to the same UI view plus 200. Of course, the leading space can't be equal and plus 200 at the same time, so that's why there's a conflict. In this case, we'd find the redundant constraint and delete it or change its priority. Each line in this log will represent one constraint, so even if you've created several constraints with the visual format language, you'll see one line per constraint here. A more visual tool for understanding where views are and what constraints are defined is the Debug View Hierarchy button. At runtime, Xcode displays this button, and when you click on it, shows a snapshot of the current view. You can then click on each view in the hierarchy and get information about its constraints in the size inspector, or click on the constraints themselves and get information in the object inspector. There are several debug methods that come in handy when trying to understand issues with a layout. You're not going to use these in production code, but you can type them into the debug console or even hook them up to a button temporarily. Just make sure to remove that code before you move on. The first one is Auto Layout Trace. This will print the view hierarchy from the specified view on down, and it will show if there are any views with an ambiguous layout in the hierarchy. Next is Constraints Affecting Layout for Axis. You pass this horizontal or vertical for the axis, and it will return an array of all the constraints that are impacting the layout of the specified view in that direction. This is helpful for narrowing down to only the constraints that impact one view in one direction. Finally, you can use hasAmbiguousLayout to return a simple Boolean indicating if this view is not completely constrained, and exercise ambiguity in layout to randomly change the frame of a view to another valid value. This can be useful to visualize how the layout is ambiguous, but because it picks a random valid value, it may not change the layout, even if it is in fact ambiguous.
For this demo, we're going to take a look at several projects that we have created and see if we can identify what layout issues they have and use our debug tools that we learned to find what the problems are and resolve them. We'll start with this first project. We're creating some fields in code. We're creating some constraints for those views, and let's just build and run and see what happens. and we're not really getting anything in our view, and that's not what we expected. We wanted to see some views in here, and we're seeing a lot of output in the console. Let's take a look at what this is telling us. I'll just create a little room for myself here. And we're seeing several NS auto resizing mask layout constraints that are on our label, on our search label, on our text field, and they're not just on the top level view. So that's a good hint that we probably forgot to turn off translates auto resizing masks into constraints for each of these views. Let's go try that. Okay, let's build and run this. Much better. So we're not getting the console output, and the views look the way that we would expect them to. So that was the problem with this one. We just had forgotten to turn off translates auto resizing mask into constraints. Okay, let's look at the second one here. And let's build and run this. Okay, this isn't what we expected. We wanted the search label to end here and the field to start a standard distance away from it. And right now the text field is a lot smaller than we expected and all the way over to the right. Let's see if we can figure out why that's happening. We have our translates auto resizing mask into constraints false, so everything's good there. Let's try setting a breakpoint. You might think view will appear. Be a good place. Let's try that. Build and run. Let's use our auto layout trace. So we'll just type print object. Now the first thing that I want to note here is this warning, missing host constraints. The problem with setting our breakpoint in view will appear is the top level view has not been installed yet. So it's actually too early in the process to try to look at what's going on with our constraints. So we could try view did appear, but really a better place to set this breakpoint is in view did layout subviews. Let's turn this breakpoint off. Let's build and run that. And let's just bring up the same auto layout trace and see what it says. So now it's telling us there's an ambiguous layout. It's not telling us that it's missing the host constraints because this view has now been installed in the window. But it says that there's an ambiguous layout for label and for the text field. Let's see if we can understand why those are ambiguous. First, I want to find which subview the label is. So I just want to print view subviews. And the label is subview number 2. We're going to use constraints affecting layout for axis. And the axis is horizontal because it's not laying out correctly in the horizontal direction. This shows us all of the constraints that are affecting the size of our subview in the horizontal direction. So we have a content size layout constraint, and it's got a hugging priority of 250 and a compression resistance of 750. It's got some other constraints. We could keep going through here and print this information on several different views, but nothing's jumping out right away. Let's look at the debug view hierarchy. Let's start this over. Zoom in here a little bit. Okay, so we can see here that the search label is too wide and the text field is too small. If I wanted to look at the constraints on these, I can click on Show Constraints, and I can look at the Object Inspector or the Size Inspector and see more information about the constraints that are on this view. One thing to note when in here, a lot of these views are composed of subviews themselves, and the trace will show you all of the views and subviews all the way down. So for example, this button has a label inside of it and then a button on the outside. And it's the button on the outside that has the constraints. So if I just click on the interior of this, it's not showing me any constraints because there's no constraints installed there. For some views, like this text field, that makes it a little bit difficult because the subview is the same size as the parent view. And you can just click and drag this to the side to see a 3D representation of the view. And now we can see that view back behind the subview. I can click on that, and now I can see the constraints that are on my text field. So the problem is almost certainly having to do with the priority of the content hugging priority constraints on the label and the text field. Let's go take a look at that. Remember, when labels and text fields are created in code, they have a content hugging priority of 250. If you create a label in Interface Builder, it'll create it with a default content hugging priority of 251. And that's really what we want here. Let's build and run this and see if that fixes it. Yep, that was it. The content hugging priority of the label and of the text field were the same, and so it was ambiguous which one should grow and which one should not. All right, let's take a look at the third project. In this project, our layout is being created in Interface Builder, not in code, and we can see an error right away. So this error button shows us that there's errors with this layout. If we start clicking around, we can find where the errors are. It's on this text field. Let's see what we can find out about that. Okay, so it tells us exactly which constraints are conflicting. That text field has a constraint to its leading margin, and it has a constraint to its trailing margin, which will imply a width. And then it also has an explicit width constraint of 100. So those are the constraints that are conflicting with each other. You can click this red button and it'll ask you if you want to fix it by deleting constraints. So I could just mark this checkbox and click delete constraints. If I really want the constraint, but I just want its priority to be different, or I want its value to be different, of course I'm not going to do this. I'm going to go find that constraint and I'm going to edit its constant or edit its priority or something like that. But in this case, I just want to delete the constraint. All right, and now we have no auto layout issues left, and the button is gone, and everything's happy.
Well, that's it for this video tutorial. As always, we'd like to leave you with a challenge. For this challenge, we've provided a couple of projects that have layout issues. You'll use the methods you learned in this tutorial to find the issues and solve them. All the details are in the challenge document. I hope you enjoyed this tutorial. Thanks for watching. We'll see you next time.